All right, welcome back. Today, we're diving deep into a battle that's raging inside every single one of your devices, right now. It's this constant fight for your processor's attention. And really, it's a story about two totally different ways to handle the absolute chaos of the real world.
I mean, seriously, have you ever stopped to wonder how your computer juggles so many things at once? How does your phone know instantly when you've tapped a key? Or your laptop react the second you move the mouse, all while it's doing a million other things in the background? Well, it all comes down to how it listens for things that need its attention.
So let's break this down with a really simple analogy. Imagine you're waiting for something to happen. You've got two basic choices. The first one, we'll call it the phone call method. You're just constantly picking up the phone to check if someone's calling. Annoying, right? It's so repetitive and it just eats up all your time. But then there's the doorbell method. You just chill. You do your thing and you wait for a visitor to actually ring the bell. You're free until you're actually needed. This choice, this simple idea, is literally the heart of our entire discussion today.
All right, let's talk about that phone call method first. In the computing world, this is known as polling. And look, it's the most obvious way to check for things, but you're about to see it comes with this massive hidden cost.
So what is polling exactly? Well, it's basically a software protocol where the CPU, the brain of the operation, is programmed to just ask over and over and over again if any of its connected devices need anything. It's just this relentless, repetitive cycle of, hey, you need me? Hey, you need me?
And this visual just nails what that looks like. The CPU gets stuck in this loop. It asks the keyboard, you good? Then the mouse, got anything for me? Then the network card, what's up? And then it does it all over again. Forever. It doesn't matter if anything is happening or not, the CPU just keeps on asking.
So, what's the big deal? What's the real consequence of all this? Well, the CPU gets trapped in what we call a busy wait state. Think about that. It's busy doing absolutely nothing productive. It's just waiting and checking. And because it's always busy, it can never save power by going into a sleep mode.
And here it is, the staggering cost of all that pointless work. With polling, your CPU can be running at 100% utilization, just burning through cycles and electricity, even when you're just staring at your desktop and literally nothing is happening. I mean, it is the absolute definition of inefficiency.
Okay, so there has to be a better way, right? Of course there is. Now let's talk about the doorbell method and see how it builds a much smarter system. This way is called interrupts.
An interrupt is basically the polar opposite of polling. It's a hardware mechanism. So instead of the CPU constantly asking, hey, you need me? The device itself, your keyboard, your mouse, whatever, sends a direct signal, an interrupt, straight to the CPU. It's like it's yelling, hey, I need you right now. And this is absolutely crucial, because it frees up the CPU. It no longer has to waste all its time checking on devices that have nothing new to report. It can focus on actual important calculations. Or even better, it can go into a low-power sleep mode, waking up only when that doorbell rings. And that is the secret sauce to both high performance and long battery life.
Okay, so the device rings the doorbell. Then what? How does the CPU actually answer it? Let's get into the mechanics of how this works.
The moment an interrupt happens, the CPU immediately stops whatever it's doing and runs a special piece of code. This is called an interrupt service routine, or ISR for short. You can think of the ISR as the specific playbook for how to handle that particular visitor who just rang the doorbell.
Now, this whole process is incredibly fast and elegant, and it happens in 5 key steps. First, you get the trigger. A hardware event sends an interrupt request. That's the doorbell chime. Second, the CPU quickly saves everything it's working on so it knows exactly where to pick up later. We call that context saving. Third, it looks up the right response in a special address book called the interrupt vector table. Fourth, it jumps to that address and runs the special handler code. That's the ISR. And finally, once the job is done, it pulls its old work back out, restores its state, and seamlessly resumes the main program like nothing ever happened.
Now, because an ISR literally stops everything else dead in its tracks, the golden rule is you have to keep it incredibly short and fast. The whole goal is to just swoop in, grab whatever data you need, clear the flag to let the hardware know you've handled it, and then get out. Any heavy lifting, any time-consuming calculations, you pass that off to the main program to deal with when things are less urgent.
Of course, in any modern system, you don't just have one doorbell, you've got dozens all ringing at once. So to manage that chaos, chips use a dedicated piece of hardware called an interrupt controller. The best way to think of it is as a doorman. It stands at the front, sees all the visitors, and decides who's most important and gets to see the CPU first.
So we've seen our two contenders. In one corner, we have the relentless checking of polling. In the other, the on-demand signal of interrupts. Let's put them side by side for the final verdict.
And this table really tells the whole story, doesn't it? Look at interrupts. Response time is near instant. CPU efficiency is super high because it only works when it has to. And power management? Excellent. It enables sleep modes. Now look at polling. Response time is slow and unpredictable. Efficiency is in the toilet because of that busy wait loop. And power management is just awful. Really, the only place polling even gets a point is on simplicity. It's often way easier to just write a simple polling loop than to set up a whole complex interrupt system.
So after all that technical jargon, why should you care? Well, because this efficient, interrupt-driven design is the unsung hero behind pretty much all modern technology. It is the reason your smartphone feels so snappy and responsive, and it's the reason its battery can last an entire day instead of dying in an hour.
And that brings us to the final, really interesting question. If interrupts are so obviously better in almost every single way, why does polling even exist? When would you ever choose the simple, inefficient option? Well, that's a question of trade-offs, and figuring that out, that's what separates good engineering from truly great engineering.